Hey, all, Brad here with another quick video. Maybe not quick, depending. This is another one on my workbench, not my test bench where I normally do most of the videos. I did a video a few back on a Type 1 Williams soundboard. It's used on Defender, but it's used on a lot of pinball as well. And I came up with a method to reduce the hum and noise and reduce the gain on the amplifier because it's definitely clipping some of the signals that come over. So um, had one of my friends out there that I've bought a couple games from, a couple rare games where we've done some work together in the past. His name's Brian, and he's been having an issue with the Stellar Wars soundboard, a Type 1. So he wasn't sure if it was the board or something in the cabinet with power, maybe, or something like that. So he wanted it gone through anyway. It's got all original caps and things like that. So send it in. I got it. I got it maybe about a week ago. I've been working on it again, setting the bench up, and then I ended up. I'll show you. I modified my tester to be able to run through all the tones on these. So um, again, his concern was, hey, as received, did it work? Yes or no type thing. So got news on that. Let me switch over to the bench cam. So again, here's the Type 1 board on my bench here. I've got my little bamboo box I showed in the last video that I like. So Type 1 soundboard. This has a large axial capacitor on it. These will all get changed out. Get a cap over here that'll get changed out. I'll pull the fuses, clean them. All the Molex headers will get changed out. This one on the pinball, some of them they actually put the volume pot on the board on the Defender that used the Type 1. This was bypassed and the pot is external. So let me just kind of go over. Someone's been over this board quite a bit over the years. Some of the components were changed for sure. Let me here. I've got a zoom function I built in. So this capacitor's been changed. Pretty certain of that. You can see the flux all over the board. I guess the term is reflowed that they do. They go over and hit. You can just see the flux gobbed up all over the place. Let me find my little here it is. I have a little pokerator. So we're looking here. We've got flux down here, all up in here. Both of these transistors. These are for the uh, voltage monitoring. I'll pull the CPU and reset if the voltage comes too low on the plus or minus power. Uh, Over here, this is the one of the 4000 series. 4011, you can see that's all fluxed up. Someone's hit that pretty good. This is the 6802 CPU. On these earlier ones, they actually use the 6802 that has internal RAM. The later ones, a lot of them use the 6808 with the external 6810 RAM. So it's kind of interesting. These big caps definitely die over time. They lose capacitance and dry out. This one doesn't have any signs of leakage, but it's going to get changed anyway. We'll come down the board. This is kind of nice. Here's the TDA 2002 amplifier, and this is all the pins and everything are gold plated on this one. It's a Motorola. If you look at the date code on there, it's 7926, which is the 26th week of 1979. And then some of the other parts on here too, you can see this is a ceramic Motorola 1408. This is the digital to analog converter that actually generates the sounds. Somebody's reflowed again, hit these solder joints pretty heavily, but 7932, so 32nd week of 79. Seen a theme here. Here's a 7933, 33 week of 79. Same part, 7933. This is the PIA, the 6821, and this has a 7922. 22nd week. The sound ROM on this is sound ROM 1. I think they use this on a couple different pinball games, but interesting, this is a mask ROM. So what that means is most of these use it like a 2716, 2516, 27, 2517 maybe it is. I'm not sure. There's an oddball one they use, not in the arcade, but um, a lot of times they're EPROMs, right, where they've got the little glass window and you can use UV to erase them and then reprogram them. But what a mask ROM is basically is the vendor like Williams would actually give the binary image, the code to the vendor, and the vendor would put it right in the chip before they encase the die typically. Or there was also a time there when they were called OTP, one time programmable. So they would come blank. You would program them, and then there was no window or anything. The cost to put that window in it was omitted, so it was cheaper to get mask ROMs essentially if you had a large volume. All these little jumpers up here could be set to do different things. This one still has the nice logo on it. I should probably flip that to make it a little more tampering with or remove this label. Voids warranty. Uh-oh, I'll be sure to leave that. And the crystal, you can see again here, it's got quite a bit of flux around these little capacitors that they use to generate the frequency for that. These are 3.57954 megahertz. Pretty standard on these. So overall, she looks pretty good. Volume pot's clean. Heat sink on the amplifier looks good. I'll put new compound. I'll take the screw out and clean out the old dried stuff. Same with the 7905 regulator here. That one also has gold-plated leads on it, which is kind of nice. It's a shame somebody hit everything with so much gobbed up solder on stuff. Again, this electrolytic will get changed. This one will get changed. These three over here will get changed. The large one will get changed. I'll pull the, let me zoom out a little bit again. I'll pull the all the socket chips, the CPU and the ROM, and I'll clean and straighten the legs on those and polish them, and just generally go over the whole board, clean it up. And then again, the Molex headers will be replaced. And then on the back of the board here, we'll kind of go over. There was a modification Williams sent out here on the CPU for pins 39 and 40 to bridge them together, and so this was already done on here. So I think some of the earlier ones got out without that, but then they later started doing it. So this probably left Williams with that bodge already in place. It wasn't on the circuit board. So, but just in general, a lot of flux, a lot of rework looking stuff all over the place. I'll clean all that up before it goes out. So on the bench here, I do have a little 4 ohm speaker that I put up here. I will plug that guy in to the speaker output. And then, so what I have here is, I've showed this in another video, but I have a little Arduino board, pretty standard thing. And they have these little daughter hats for them, they call them. And just a prototyping board. So I built that up to take digital outputs here to drive the inputs that normally come, well, on an arcade game from the ROM board from the MPU on a pinball machine. So they're actually non-sequential. So like bit 0 isn't pin 2 and so on and so forth. They're just kind of random based on how they routed them. So my pinout matches that. And again, I have let me get this here. I have the mating connector here for that. And it's keyed also with that first pin plugged. But I ran everything through a 74LS244. So basically, what I can do is load up what I want the output to be, and then I hit the enable on this, and it shifts them all in one time over. Because the problem is, Arduino is a CPU, and it's sequential, right? So as I'm saying, I want this bit on, this bit on, this one off, that one off. It's going through and turning the states on those, and you can get kind of a race condition or an issue where if the CPU that's reading those inputs gets one that's mid transition, it was falling and rising. So by using this 244, I shift everything in at one time, and then I pull them out. I set them all back to floating, tri-state them. That's what this does when you disable it. Goes to tri-state. It just floats, and then there's pull-up resistors on the board that keep everything at 5 volts. So I basically release it. It goes back to normal. I set the next sound that I want, and then I shift it all in one shot. So what I did, it took some time. I went through and mapped. Got my little handwritten notes here as kind of proof. So I just went through and listed these have potentially 0 through 32. So I went through and just went through all 32, and then I have a little device I use. It's not on this bench right now. It's a way where I can manually drive these inputs with the little dip switch in any case. So I went through manually, mapped out all 32, which ones had sounds, kind of made a note what they sounded like, and then I programmed them in here so it goes through and will cycle every single sound. I also went through and used a cell phone to capture the musical note for each one of them, and I plugged it into ChatGPT, and I had to do a Star Wars theme and stuff like that. I have it working. I didn't load it in this for this video, but I have it where this thing will play the Star Trek theme song and the march as well. So let me plug this in. So spoiler alert, it did work. There was a pin here on the CPU on pin 1 that was bent back, and I thought, oh, that's probably it. Well, after looking at the drawing, the pin out on these CPUs, that's a DSS, which is a ground, and there's multiple ground points on these. So I think even with that bent in, it wouldn't have caused a problem. So I'm going to have to say, as received, maybe something got shifted in shipping or something like that. But basically, when I put it on the bench and plugged it in and hit the test button here, it works. So I'll start with just, I guess, hitting the test button. Let me go ahead and mute my mic, and I'll switch over to the the one on the camera, because this mic I'm using here is pretty good at sound canceling. So I'm going to hit the test button here. Oops, it helps if I put power on it, I suppose, right? So there's power. Now what I'll do is, again, my little tester here. I'll just go ahead and bring some 5 volts into it. You can just power it off the USB too if you want, but when I plug in power, it will start playing here. So she'll just sit there and loop forever. And usually what I do after I work on these boards and fix them, you put the tester on and then I'll just continuously loop them. I'll either turn the volume down, but I like to have a load on the amplifier. So sometimes I'll replace the speaker with just a high watt 4 or 8 ohm resistor that can dissipate the heat. So we get a little current flowing out of that amplifier, let it get warm. And I'll let them run overnight just to make sure everything's rock solid. So the plan with this board is I'm going to strip down all the components I'm changing, Molex headers, caps, all that stuff, pull the fuses, pull the heat sinks off, get new compound in there, clean all the socketed legs, and then polish it up. And then I'm going to let it run on the bench for 24 hours and basically calling that a rebuild. Repair is a little overreach since it's working, and we'll get it back to the customer. So thanks for watching the video. Any questions, put them down in the comment section. Thanks.